Yeah, let's move that off. Okay, let's just keep playing the game then. Countdown, year 19. Yes, welcome back. That's me. Tick, tick, tick. Time keeps ticking down. Let's get to work. Oh, yes. I love when you're done with your hair. Right, we've already played this one, almost. So what was the issue with this one? I basically got too kind of wrapped up into it to be able to actually finish it. But there's 6, and then I subtracted that and got 5. And then, was it an issue with negative numbers, or it was an issue with, like, when they got down to 0? That's what it was the 0 case. Well, I'm gonna watch this play out for a second here, just to remember what I was doing. And then we'll go from there. 3, 2... Okay, so we get 1. And then, what happens when we get to 0? With 0, we put that in there. Then we jump to the start. So we put in -7. Okay, that's correct. Ah, I remember what the issue is, I think. I think it was the issue with 0 input. So if I speed this up, it should get me down to 0 just fine. 3, 2, 1. Yeah, so the issue is that it puts down... If it's 0, for whatever reason, it puts down -1. So let's step back a second here and debug this situation. So what I did was I went back over here and copied from 0, and then since it's not negative, I assumed that it was... Yes, okay. Since it's not negative, I assumed that I was holding like an... Yeah. So I subtracted 1 from it. I assumed that if it was not negative, I was doing a... It was a positive number, as opposed to being less than or less than 0. So this since it's this needs to check if this is 0 earlier. So if it's negative, then we check if 0. And I think this probably didn't work, but I'm gonna see what happens. 5, 4, 3, 2, 1, 0. Yeah, I put down 0 twice. Alright, so here's what I'm going to do. I'm going to scrap all this logic entirely because I don't really remember it. And we're going to start fresh. So we pull in 9. And then we need to test. Well, first we copy it into our register here. And then we test if it's 0. If it's 0, then we outbox it and start the program over again. If it's not 0, then we enter our loop here, where we outbox whatever the current value is. We test if it's negative. If it's negative, then we increment it, and then jump over the body of decrementing it. And then we jump back to this point. I think this might do it. So we put down 9. Then we outbox it, and then I'm not holding anything. Right, so I need to do a copy. I need to do a copy from statement here again. Okay. Let's try this. So I put down 8. We copy from 8. We outbox 8. Jump empty value. You can't jump if negative with empty hands. Right. Okay, so we need to outbox later. After we do our decrementing processes, that's when we outbox. Alright, so this will probably not work because I'll be... Okay, first off, I got my bumps incorrect, so I need to swap those around. So, like that. And then I need to outbox this right away, then start the process. So I think I've basically rebuilt more or less what I was doing earlier, except that I need to... I really, really wish that when you outbox something, you still kept a copy in your hands. It's kind of weird that you don't do that, in my opinion, but what do I know? I didn't make this game. So we put in 2, which is wrong because we wanted to put in 3 first. So let's just do this a little bit inefficiently for right now. And then worry about doing it correct, like shoring it up later. Hi, Purple Phantom. So we outbox 5. We're still not holding anything, so I need to go back and I need to copy from 0 again. And then I can get rid of that. This actually seems alright. So I put down 6 and then copy in 6. And if it's 0, we don't do anything. We put in 5. This looks good. Hi, Purple Phantom. This is looking okay. And I think that I actually had code that was really, really similar to this. But I again, like, it helps, because I haven't looked at this in a day, so it's completely escaped my short-term memory, so it's a short enough program so that I can rederive it pretty easily. So we jump back, and we don't need that outbox statement there because we've reached 0. That looks actually really good to get rid of that last outbox statement there. Okay, this looks good. I think this is the correct solution now. Well, no, I think this is a correct solution. A little bit iffy on the performance because we have these 2 outbox statements and then a copy there. Something about that seems really bad. But this should work, and then I can mess with it a little bit. I said hi to Purple Phantom twice. Hi, Purple Phantom. You get a hi for every hello that 7wags has never gotten. Okay, so let's just keep watching this. I think that when it gets to 0, this should have the correct behavior because we outbox no matter what, and then we stop after. Then when it's 0, we just stop. So then we pick up 0, and then we jump and then discard it. Okay, we put down 5, or negative 5, I should say, and then I've incremented it to get negative 4. This looks extremely promising now. I do like this. So I'm going to speed this up a little bit. Okay, so there's 0. Now we test 0, it's fine that it's 0. So we've outboxed 0, and then we should test 0, find that it's 0, and then throw it away. Aha, this looks perfect. Okay, so we've solved this puzzle. Congratulations, Bird. I've done it. And I hold... Yeah. I did this really badly on both fronts. Oh no. Okay, so issues were definitely this extraneous copying and the fact that I outboxed right away. But I did solve the puzzle, that's the important part. What happens if I remove this outbox statement? I don't think this is going to work because I'm going to immediately decrement it and then lose that first value there. Yeah, okay, so we're not going to worry about optimizing this. I'm mostly interested, like I said, in just beating this game and then coming back and optimizing stuff. Multiplication. So I assume I'm getting a multiplication instruction now. It seems like yesterday we were learning about adding. Fond memories. We worked so hard back then. For each 2 things in the inbox, multiply them and outbox the result. Don't worry about negative numbers for now. Get labels. You can remember the purpose of each tile. Ah, so I can name my registers now. Or rather, I can name my local variable / register / whatever the hell these things are. Okay, cool. So let's remove this one, which gets rid of... Ah. Oh, okay, cool. So I can choose to name things now, so I can call this... that, apparently. And then... I can, when I say copy from, it gives me like the label, the name that I've attached to it rather than the, just the register number. Cool, good documenting. Okay, what was I doing? I was multiplying things. So, I needed to, so I have a 0 value for whatever reason. If I had a loop earlier where what I was doing when I was trying to implement multiplication earlier, and I did it wrong because I wasn't able to do anything with negative numbers. So if we have this 0 value, what the hell can we do to that? I mean, that doesn't seem useful at all to have just a 0 value here. But if I bump it to get 1, then I have something I can subtract stuff off of. But I don't need that because I have this decrement operator. Right, okay, so that's fine. So... multiply them and outbox the result. So the very first thing I need to do, inbox that one, and I'm going to copy it to this, which I can give the name of, let's see, what was this? This can be I, and then this will be mult. Wow. We're gonna pretend that nobody saw that. Okay, so and then we need another register for, we'll call this base. Let's try that again. Base. It's weird that it applies like some vector smoothing to your handwriting there, but I kind of like it. All right. So I is going to stand for our loop counter. Base is going to be our base, so we're adding 5 to it, and then mult stores our temporary value. How far along we are. It stores our final value. Okay, so first we copy 4 to I, then we inbox again to get 5. We copy that to base, and we copy that to mult? No, we don't do that yet. I mean, we need to copy, actually, if we copy 0 into that, that works really well. To do it that way. Or we can do, wait, let's just copy, we'll copy again into mult for right now. I think that I might be doing it wrong to do it this way, but I'm not really sure. Okay, so then do I want to multiply 5 by 4? Yeah, it would be slightly more efficient to do this in the other order. So we're going to switch these around just a little bit, because that way I'll already have in my hands what my loop counter is, because that's the first thing I need to test. So if it's 0, then we just multiply to, let's see, 4, 5, 2, 6, 9, 0. That'll be 0, 9 times 0, so we should return 0 in that regards. But we'll be testing 9, so we'll be returning 9. Okay. So, the very first thing I need to do is instead of loading, so the problem is if we load like 4 into our temporary multiplication thing, when we multiply by 0, that doesn't work. So I need to copy this 0 value over there instead. So to do that, instead of copying to mult, we copy from 0 and we copy to mult. So that loads up the proper, yeah, that's great. Okay, so that should be before we grab our loop, so that everything is nice and efficient, so we can just go right into testing with our loop counter, as opposed to moving around and making sure I'm holding the loop at the very beginning. Alright, so let's comment this as loop. Okay, this is loop cond for loop condition. And this comment is fucking enormous, and it eats up a ton of space here, and it's really not quite long enough. So let's go ahead and just say that this is cond now. So that's short for loop condition. Alright. So if it's 0, then we return whatever is in our mult. So we copy from mult, and we outbox, and then we jump to the top of the function. If it's not 0, we decrement I, and we add base. No, we copy from base and add it to mult. And then we jump to the top of our loop there. Okay. And then, let's see, decrementing returns. Okay, that should be fine. Cool. So now you can see that it's really way easier to program when you can name things. So we decrement that, pull in 4, add it to 0, let's get 4. And we pull in 4 plus 0, and I'm not storing the value back in mult. So add to mult and then copy to mult. There we go. So we pull out 4, and then we put 0 in our multiplication result, and then we grab 3, so this should return 12, of course. So put 4 in there. And then... Oh, no, it's copying... What is it doing? It copied something into I. Ah, I need to copy from I, not copy to here. There we go. I was like, I'm grabbing the wrong thing. This is not quite right at all. Okay, 8 times 4, so we need... Can I copy from an empty value? Copy to I. There we go. This is correct. Okay. Again, this is a little bit weird with the copying that I'm doing, so it's probably not the correct solution, but whatever. So put in 3, and then we decrement it and grab 2, which makes no goddamn sense, but whatever. So we put down 7, pull out 1, decrement it, and grab 1. We now add 7 again to get 14. We store it in there. 0, 7, 7 plus 14, 21. We test 0, we grab 21, outbox it. This is the correct algorithm. Yep, so naming things works wonders in terms of, like, your understanding of how a program works. And beforehand, it was, like, a bunch of, like, weird magic values, and I had to kind of keep track of what everything was doing on my own. But now, and I can just, like, figure this shit out. Not to mention the fact that if I return to this later on, like tomorrow, for whatever reason, like I can't figure this out, then I would not have like nearly as much of an issue, because I'd be able to like just jump back into my code, see what I named things, and then figure it out. All right, this works out perfectly. So let's go ahead and just speed this up and then move on with life. So that adds 0 to 0 3 times, which is perfect. And this should give us 35. Cool. All right, so that was that one. Again, not exactly the most efficient solution. Not even remotely close. 16 steps, which means I did not accomplish speed at all. Wow. So, I did pretty shit there. But at the very least, I accomplished it, so I'm okay with that. And then Grove can come in and talk about how much better he has at assembly programming than I am.